All right, next up we've got Henry Dean. Hey, Henry, good to see you.
Hello, Chris. How you doing?
Give us a little background on yourself.
So I've been a freelance character artist and technical director for the last 7-8 years or so, and for 5-6 of those years I've been working exclusively with Houdini. And over the last nearly couple of years, I've been happily working on the KineFX toolset, which we'll be looking at in this presentation.
Excellent. So what parts of that are you going to be covering in this one?
So the scope of the toolset is very, very broad. There won't be time to cover all aspects of it, but what I'm hoping to do is to cover some of the fundamental ideas and some of the philosophy behind the development of the tools and what the implications of that might be for everybody's future character work.
Excellent. Well, let's get started.
Thanks.
Hello and welcome to this presentation on the KineFX framework new in Houdini 18.5. So the KineFX framework marks the first step on a journey to reimagining the rigging and animation workflow in Houdini. In this first iteration, we've got some really powerful tools for motion retargeting, and this was one of the original mandates of the toolset. As development continued, this expanded in scope and is now part of an ongoing project to encapsulate the whole of the character animation workflow. For the retargeting side, I'm not going to be touching too much on that explicitly, so Mithna and Bogdan will be coming back with talks later on that will deal expressly with these tools. For this presentation, I just wanted to have a little play, discuss some of the fundamental concepts and give an idea of where you can take these tools in helping with your workflows. So on we go to the fundamental ideas behind the toolset. And the big one, of course, is that we're moving everything into the geometry context. And really, this is just a small part of the character rigging process that's being moved in to SOP. So blend shapes were always geometry. Anything that was driven by a curve or was adhering to a surface, all these kinds of constraints, they were also driven by geometry. And of course, the final deformation is geometry. So it was really only the bones or joints and the controls that the animator works with that lived outside of this space. So KineFX brings all of that into this same context. The next little note that I have here about the design of the tools is that world space is king. And this is a really important idea. The points in KineFX and the tools that operate on them, they very much view the input world transforms as being the ground truth. We don't want to change our input unless we explicitly say so. So any local space transformations are computed per operation, which gives us a huge amount of flexibility in doing things that would have been prohibitively difficult working at object level or with any kind of static scene graph. As a little example of this, I'll just jump over to Houdini. And here I've got a very simple retargeting setup that we'll be making use of later. For now, I just want to focus on the skeleton we have over here. It's being brought in by the FBX animation import node. As I scrub backwards and forwards, we can see the motion. Now, all we have on these points is a P attribute and a 3x3 matrix transform attribute. The decision to break the world space transform up into these two attributes is mainly driven by the fact that every point in Houdini has a position. The moment you create a point, it has a position. This is not an optional attribute. So to avoid any potential conflicts, putting things out of sync with a full matrix 4 transform attribute, we decided to keep these things separate and leave P to handle our world space translation, and everything else will be handled by the 3x3 matrix, so rotation, scale, and shear. And as we scrub through, we're seeing the animation. We've got no local transform attribute on these points. The moment that we want to do something in local space, however, well, then we need it. But the nodes themselves recompute this on the fly. And as a very trivial example of this, I'm just going to come and put some adjustments on the head. I'll just move it up and rotate it. And now as I scrub through, you can see that the rig pose has applied this as an edit on top of the incoming animation. To prove my point, I'm going to put a delete joint sort down, and I'm going to grab a whole bunch of points. I'll just grab all of these and delete them. If I come back to the rig pose and I bypass and unbypass this, you can see that the head is staying where it's put. So as the topology changes here, the rig pose updates the input local transform before it applies its own edits. So it's a very, very powerful idea, and one that gives you a huge amount of flexibility in the kind of operations that you can perform. So this is key. If I do this the other way round, we can see another important idea. I'll just clear my edits here, and I'm going to translate this off. So having operated on a subset of the points, we haven't lost anything. I haven't deleted anything that's persistent. We still have our original hierarchy. And should I want to then take those edits and reapply them to that full hierarchy, well, I'm only a node away from copying those transforms back over. You can see that this is collapsed down, and that's because, of course, by default, the skeleton blend works in local space. The local space of the abdomen here has very much changed. So if I toggle on the world space, you can see that we're copying over the world space transforms for any joints that exist on the right-hand side. And so now as I perform any edits, we can see that flow through and get reapplied to our full hierarchy. So very trivial example, but hopefully demonstrates some of the features behind this idea. So I'll just clean that up and let's jump back to our slide. The next important concept is the idea of a rig as an operation, and a separation of concerns that comes with this. This isn't a new idea. It's a very common practice to rig using what we might call a shadow rig or a deformation rig that's a completely separate hierarchy to the control rig that an animator would interact with. And this helps pipelines keep a very clean rig for export. So especially important if you're working with game engines or anything like that, where we don't want the control hierarchy mixed in with the deformation hierarchy. It generally makes a mess of things. So it's very often a good practice anyway. And this is something that's very close to the heart of the networks that you'll see set up in KineFX going forward. We have this minimal set of joints responsible for the final deformation. How we drive those, well, we decide that over here. But we always just write back to this minimal set. So this enables us to stay organized and to keep a clean character for import and export. The next little note is just about the open architecture. The data model for the joints, the points, is very, very lightweight. The minimum attributes that are required are a 3x3 transform for the world space and a name. And the name attribute, whilst not explicitly necessary for lots of the operations, it's highly recommended that you do name points when working with the KineFX tools, and that the name should be unique per point. So the rig doctor node is one that can help you do this. There's an option to pick up the duplicate names and add a numerical suffix to them to ensure that we have unique names on the output. Of course, this open architecture, the fact that we now have access to the world space transforms at the very lowest level is hugely powerful, but also puts a bit more of an onus on us to stay organized. So the KineFX tools that are shipped with 18.5 provide some ways of helping with this. But it's something to be aware of, that when you go off-piste and start playing with these attributes directly, that you do have to stay organized and keep things clean. So, what do we have here? Revisiting a prototype. So a long time ago, I had a little play at just a little idea, really, of being able to draw out a bone chain, and this was working at object level, using a stroke sop as an input. And I did get something working, but there was a lot of Python involved, and we were also treading the slightly sketchy territory of creating objects dynamically and actually modifying our scene based upon a continuous input event, and this is already something that it can end up being brittle. So this was the little prototype that I tried to knock up at object level, and I thought it made a good use case to explore in KineFX. So let's see if we can recreate it in KineFX a little bit more easily. So I'm going to create a new geometry network, and I'm going to dive inside. Drop a stroke sop to enable us to draw, and I'm just going to resample this into the number of joints that I want. So I'll pick the default 10 for now. The next thing that we're going to need is our transform attribute, as I just mentioned. So we'll initialize this using, again, another stock SOP node, which will create this 3x3 transform for us. Drop down the rig doctor, which we're simply going to ask it to initialize our missing names. There's one more option here which I haven't changed from the default, which I need to on the orient along curve, which is, instead of using an average of the edge directions for the tangent, I'll choose next edge. And now as we come back, we can see that we've got joints that are nicely aligned to their child. Okay, great. That's our joint chain made. Step number 2. Can we retrofit a spline to drive this with a spline IK? Well, let's have a go. I'm going to fit a NURBS curve to it. Currently, I'm creating quite a lot of points to conform to this shape. So let's pull that tolerance right up. And in fact, I think we might be... Yep, so this will force the creation of 4 control points. Now, because of the input shape that I've given it, it's having to do some pretty wild stuff. So let's start with a slightly simpler curve. Okay, there we go. Something a bit more sane as an input. We've got our 4 points. I'm going to transfer the transform information from the original chain. And I'm going to duplicate this rig doctor just to do the same thing and initialize some names. And of course, I should be going back and making these names a bit more sensible. So maybe something like spline joint as the prefix. And here I can have spline control as the prefix for these. Next job is just a little bit of stuff to make it a bit easier to identify these points. And then, of course, we want to be able to move these controls, so I'll put down the rig post. So the final step is to actually evaluate the IK. So I'll plug in our original created joint chain up here, and I'll add our controls on the second input. The VOP node that we're looking for is the curve solver here. And I just want to grab all of the points from the first input and all of the points from the second input and drive one with the other. To do this, I'll use the getPointTransforms VOP, which fetches a whole bunch of transforms based upon a group. So this is going to be our joints that we want to drive. I'll Alt-click drag to duplicate that, change this to the second input, and this will grab our controls. The last step is to actually write the solution back to our points. Okay, and you can see a little jump here if I right-click and untoggle display inputs. And now as I bypass and unbypass this, we can see the effect that our solve is having. And we are getting that loss of fidelity that we would expect when we're trying to fit a curve to this arbitrary joint chain. There's one thing I forgot to do, which is to make sure that our curve type matches the type of curve that we're creating on the right-hand side. And this, you won't see a difference here for now. However, if I want to get this to adhere more closely to the curve, so let's come back and we'll clear this out. And if I come back to one of my funky earlier shapes, we can have a look at our controls. You can see that because of the tolerance I've set, we've now got more control objects. And it's given us 6. So this might be a bit much to work with when we're actually solving the IK solution. So we can always create some parenting relationships that work for us better on these controls. As it is, we already have some, and if I display the links, we can see more clearly that because these points still exist on a primitive, we've got that hierarchical information there. In order to remove that, I'm going to use a humble add-sop, delete the geometry but keep the points, and we now have a bunch of points floating in world space that I can move individually. Now with this higher count of controls, these ones aren't feeling especially helpful here. So if I drop a reparent joints afterwards, I can just grab these ones and reparent them to the controls at the very end of the chain. And this now gives us slightly coarser control over this, so we've still got these main controls up here and all the rest of it. Now, of course, we've broken a little bit we've possibly introduced the brittleness here, in as much if our point count changes up here, these names won't exist. So, we've always got to look at how we've organized things. But this is just that bit. If I wanted to stick to our 4 controls, I can just increase the tolerance, and we'll get those 4 controls on our input. Okay, so that's that. That was the recreating that prototype that I really, really struggled with at object level. Back over here. Now, as I built that, I had a thought that I've definitely got 2 steps here. So being able to identify processes and split them up and reuse them for different things, this is something that really gets brought to the fore when we're working with these SOP level tools. So if I look at the network I just created, I had one step which was to build a joint chain. Then I had another step which was to fit a spline and create the controls, and then the final step was to actually run the solve. So the thought that I had was, well, if this is just a joint chain, then maybe we can pull that from somewhere else. So let's have a hop back over to Houdini. And I'm going to jump in here. Just exit the state. And what I've done here is I've grabbed the animation from this network here, which was our little retargeting network which we saw at the beginning. And I've just object merged that skeleton in. Now, this isn't the most efficient way of doing things, but for prototyping, it's absolutely fine. So I've just grabbed that animation. I'm going to clear any posing that I've done just to keep things clean. And you can see that in the green box that we saw in the slide, I've just grouped some joints on the input skeleton. I've deleted the other ones, and I had to do an extra step here just to make sure that we had a single primitive to work with rather than the 5 that we had on the input. But that's it. We've now got our input for the spline fitting. So here we've got exactly the same network, and here's the spline IK. If I jump here, hit enter to enter the state, and start pulling these around, we can see that we've got that affecting the skeleton. Now, taking a little pause just to clock something here, which is that I said I'm pulling in an animation, so I've got an animated input to this, to which we're attaching this spline rig. And then anything I do to it is layered on top of the input. So this is a very, very powerful concept. We've basically got a rig setting itself up live from an animated skeleton. We're modifying it and then writing that change back. So this is a very, very key idea, and we'll be seeing a lot more from that as we go forward. The next little bit that I wanted to do, of course, was you can see that as I pull these things around, we're throwing the hands about. Now, this might be fine, depending on the input animation. For me, I thought, well, let's have an option to just pin those. So I've isolated the input hand and elbow positions. I've also done it for the feet. I've removed all the parenting information as we saw before. And then we've got an extra little step here, which is to attach some controls just to differentiate them in the viewport from the other points that surround it. So if I come back in here, we can see that we've just got these green points. If I come back up here, and I'll just add a control. On the right-hand side, I'm fetching some geometry from other object nodes. So I've got a simple null control here. I'm just going to hide all of this stuff. And I've got a custom control that I made using a simple circle and a transform. So back into here. I'm going to select the joints that I want to attach the controls to, and for the ends, I'll pick the custom control, which is here. And for the twist controls, I'll just use that simple null. And there we go. That's that. So now as I come back into the rig pose, I can actually hide the joints, and I can now use these bits of geometry to select in the viewport. Okay, so there's our IK working. I've still got that silly pose on the spine, which is why we're seeing some wonkiness. So let's come back and see what we've got as we play backwards and forwards. We've got the input animation with those controls attached. Okay, so we've successfully identified a couple of processes and put them together in a network. I will just touch on this very, very briefly, which is that VOPs, of which we have many new ones in the KineFX tools to perform constraint operations and IK solves, VOPs really start to shine here over writing FX code in wrangles. Many of you will still prefer to do so. But when code gets more complicated, it becomes much harder to identify what processes we can encapsulate nicely. It becomes a bit more of a mental effort, especially when we might be prototyping and working a bit more fast and loose. And building things in VOPs is really nice because we can see the input wires to our various functions, and we can see where those wires converge onto a single input value. So we can identify more like this which parts of our network we can wrap up into a single verb, if you like, a single action. So that's just a little note here. So do check out the VOPs that we have to use in KineFX that have all been designed to work with these, with transform matrices for rigging purposes. Okay, so reuse and repurpose. I mean, we've already seen that. We've taken our little prototype and we've applied it to the Erik rig. And the next thing is just to keep iterating on these setups. Once we've got a little process, we can continue to stay within it and keep refining the results that little process is giving us. So we've seen a little start of Erik's test rig. We've got our spline IK for the spine. We've got simple IK for the arms and legs. And the next thing was a head look at derived from the input. So this is very straightforward to do. We can look at the input animation for the head, offset its translation along the direction of the gaze, and use that to drive a look at after we've run the spline IK. We'll have a look at this in a second. The next little bit is the hand controls. So hands are often something that's a dead giveaway in motion capture retarget. It's becoming much more common for motion capture suits to have support for fingers, but many old motion capture files don't have animation for the fingers. So being able to add a little bit of more natural motion to the hands is something that can really bring a retargeted animation to life. I've already touched on the adding of control geometry. So this is all stuff that we can do as part of the process of iterating on things. So let's take a look back at this test rig. So I've taken all of what we see here, and I've wrapped it up into a subnetwork. If you don't know about doing this, then we can do this just by selecting a bunch of nodes and hitting this box up here, and that will wrap all of that up into a single node. So keep an eye out for your individual behaviors and how you might be able to collect them and keep your networks organized and clean. So very, very powerful stuff. The next step beyond this collapsing is to actually create a digital asset from them, and there's plenty of documentation on this, and we'll see it in all areas of Houdini. So this is definitely not something specific to KineFX. It's been in Houdini for a long time, and it is really essential to a lot of workflows in Houdini. So I've gone and done exactly that. If I crack open this network, it's not as clean. I did this before I had organized things properly. But here we've got our fitting of the spline. We've got the spline IK solve. I've then got that head look at. So if I have a look in this network, if I bypass this, this is the add joint VOP is just allowing us to debug where this transform is. And we've set this with a parameter that I've promoted. It just allows us to set the sort of gaze distance, if you like. And this is offset from, the original animation, so the head on the second input. I've then offset along the negative y-axis by that amount that we saw to the point here. And I'm using that to drive a look at constraint from the current position of the head. So this is where the head ends up after we've pushed the spine around with the spline IK. So we're looking at that, and we're just making sure we're looking at the same position as we were in the original animation, and then writing that back out. So a quick blast over this, and do forgive me for the brevity. I'll be covering this in more detail elsewhere, but this is just a little example. We've then got our setup here for isolating the IK controls. And here I'm actually deleting the joints on a static copy, a time-shifted copy. I'm deleting the joints, and then I'm copying the transforms back. I'm then unparenting everything as I did before. And what we're seeing here with the compute rig pose, the compute rig pose is the core of the rig pose node itself. So if I dive inside here, we can see that we just have a single compute rig pose node. Again, beyond the scope of what we're looking at here, and I will cover this elsewhere, but this gives us a very quick way of promoting parameters to an HDA when we want to be able to pose from a digital asset. So we can see this up here. If I just match the current definition, and I'll change the display flag here. Here I am with the locked asset selected, and the rig pose state has been built to enable it to be used on custom digital assets. So we can see the rig pose or the compute rig pose nodes contained within, and display their geometry in the viewport. Okay, so that's that bit. And if I come here and I'll just clear all of this, once again, it's worth emphasizing that we can bring in this animation and have access to this rig. The rig has attached itself, and what we're seeing here is the result of the rig on top of any input animation. Now, what we were actually here to look at, of course, was the hand rig, and the hand rig introduces another interesting little idea that's worth sharing. That because the skeleton is just geometry, and we can use geometry nodes to operate on it, we've got a couple of other possibilities. So here you can see I've got a little hand rig here. I'm going to make sure that we can see the output. And we've got a couple of broad hand posing controls. So we've got a curl control here, and we've got a bit of splay, which of course we can make these negative as well to bring closer together. And same thing on the other side. The way that I've set this up is actually I'm not using rotation parameters at all. What I'm taking is a collection of poses that I've made before, just from the rest position. And I've posed all of these here. So there's the left hand curl, here's the splay, and the same thing for the right hand over there. This is, again, slightly beyond the scope of what we've got time to cover, but I'm just wrapping these up into a single primitive and then merging them all together to make a library of poses. This little hand rig takes that collection of poses and then feeds these into a blendshape sub. So this is a geometry node. This is used for blendshapes as we would normally think of them. But for some versions now, it's had support for properly interpolating the rotation of normals, quaternions, and transforms. So we get a really nice result out of this if we just feed in these separate poses, and we can use this node to blend between them. I'm then having to do a couple of little extra bits just to conform things, but nothing too onerous. And here we have it. This is our broad control, and I've also promoted the state. So we can also manually adjust each of the finger joints after we've performed these controls, these broad controls rather. So again, I can come and grab these guys and quickly create a pointing motion. Pointing pose, rather. Okay, so that's the little hand rig. So this is cool. So we've now got these two rigs, and of course they're layered on top of one another. You can see that the hand's pointing here, and if I move this around, that pointing pose is still getting applied afterwards. But, you know, I've still got to hop backwards and forwards in the network. So this is another example of a little prototype idea. If I just want to be applying hand animation after a retarget, then I only need this one. If, on the other hand, I want to be doing a bit more, then maybe it would be nice to have the hand available to us in this rig. So I'm quickly going to run through how we might be able to do that. I'm going to open up the type properties for our asset. I just need to change how many inputs the node accepts. And I also need to add the parameters that drive this stuff. So I'm just going to take this whole network. I'm going to hit Control-C, jump back up into our rig, and I'm just going to apply these changes. Whoops. After the rest of the rig has run. And then the output will be this. We can see the warning here on the blendshape node, and it's just telling us that, firstly, it's telling us we've got bad parameter references. So this is because I haven't added the parameters back here. The other problem that we'll have is that we haven't actually got our little library of poses. So the first thing is to just butcher the controls from the hand rig. I'm just going to drag those over here. And Houdini will actually create references back to those parameters, so I just need to make sure I clear all of those. And I'll hit apply, and we should see that we get another warning here telling us that we haven't got enough inputs, basically. So I'm going to find my second input that I've just created. So I'm zoomed out a long way. Bring this, plug that in. We're getting a little warning. Not enough sources specified. Well, no, you're quite right. I haven't connected our library of poses. Okay, and we have one more step to do, which is just to rename this parameter. So I'm going to say hand transformations, and I'm going to promote these parameters. Just going to close this here. We'll come back up, clear any edits, and we'll see that we've got a new bunch of parameters here. Now, of course, we can organize these better and make things look nicer afterwards. But there we go. There's our hand transformations parameter. I'm going to save the node type, match the current definition. And you can see in our state, we now have access to all of this, including our broad controls. And everything's hooked up. So that's an example of keeping on iterating, exploring these atomic processes, and then still being able to merge them all together, extend assets that you've already created. I'm now going to just delete out that asset, and there we go. Once more, having saved this, I can now drop this into another network. I'm going to look at my Hive test rig here, and I'll plug that into the animation. Oh, I haven't got my hand poses. This might be a design flaw. It's certainly something that we can rectify later on. I'm just going to copy and paste this in for now. Okay. And this is now attaching itself to the input. You can see that I've already got the hand curled up here. Bring that back to normal. And Houdini being Houdini, if I change the input animation, let's see what we've got. I did have another one available to us. I can't remember which one I was using that was a good example of this. Let's just try the first one, and we'll see what we get. Okay, so we've changed the input animation. Okay, there we go. And this rig is, once again, still attached. And this does make a nice example, because as the animation goes forward, we can see that there's a contact point just down here, which is completely wrong for this character. So we can use our rig to adjust this, and I probably want to start where the hands aren't colliding, add a keyframe, scrub onwards, and just start positioning the hand where it makes a more sort of natural pose for the character that we're dealing with at this point in time. Obviously there isn't time for me to do a proper polished job of this, but we can see the principle is there of being able to use this little custom rig to refine our retarget and get the results just how we want them. Okay, so I believe that covers everything that we have here. As I've already alluded to, this is just the beginning. We're definitely not dusting our overalls off and calling it a day for the world of character work. We're very aware that there's long ways to go in providing the kind of interaction that you would be looking for doing full character animations in Houdini. So we will be earnestly improving the toolset as we go forward. And in the meantime, we really look forward to seeing what you guys do with it, and look forward to hearing from you. So thanks very much for watching, and I hope you enjoy the tools. Bye for now.